Take a look at the shirt you're wearing right now, or maybe the jeans you've got on. The threads, they're woven together with this incredible precision, right? It creates this perfectly even fabric. And honestly, it's something we totally take for granted every single day. But have you ever wondered how that actually works? I mean, how does a massive clattering loom make sure that every single thread is spaced exactly the same distance from the one before it? We're talking over hundreds, sometimes thousands of meters of fabric. Well, the answer? It's just a beautiful little piece of mechanical engineering. It's actually hidden away right inside the loom. Just a small, kind of unassuming collection of gears that, believe it or not, does one of the most critical jobs in all of weaving. Okay, so let's dive in and see what's going on here. Weaving's perfect rhythm. Yeah, that's what it's all about. To really understand how we get that perfect fabric, we need to zoom in on the specific mechanism that controls this perfect rhythm. Okay, so this whole process is called the take-up motion. Now, that might sound pretty simple, right? But trust me, it's a process of incredible precision. As the new fabric gets woven, this mechanism has to pull it away, take it up at an absolutely constant rate, and then wind it onto a big roller. So this take-up motion really has two main jobs. The first one is pretty straightforward, right? It just has to wind up the finished cloth. Easy enough. But it's the second job where the real magic happens. It has to maintain a perfectly uniform number of those crosswise threads, we call those picks, for every single inch of fabric. That is what gives your clothes their specific density and feel. Inside the five-wheel system. Now, there are a few different ways to achieve this kind of precision, but we're going to start with a classic, really robust design, the five-wheel system. So here it is, a diagram of its gear train. Now, this is what's known in the biz as a positive intermittent motion. And that's just a fancy way of saying two things. It's positive because it's all driven directly by gears. There's no slipping, no friction involved. And it's intermittent because it moves in these tiny, precise little steps, not in one smooth, continuous motion. Okay, so here's the play-by-play. You've got the main part of the loom, the sleigh sword, and it's swinging back and forth with each new thread. With every single one of those swings, a little hook, called a pawl, grabs onto a toothed wheel, the ratchet wheel, and pushes it forward by exactly one tooth. And that single tiny little click of movement gets transferred down through all five of those wheels, making the final take-up roller turn just a tiny bit. It's just enough to pull the new fabric forward perfectly. But wait, here's the really clever part. See that gear called the change wheel, or CW? That single swappable gear is the key to the whole thing. It's how you control the fabric's density. By just popping one out and putting in another with a different number of teeth, a weaver can completely change the fabric's picks per inch, the PPI. And the relationship is all governed by this beautifully simple formula. So that 2000 you see, that's the loom's constant. It's a fixed number based on how that specific loom is built. You just divide that number by the number of teeth on the change wheel you picked, and boom, you get the exact PPI. It's so simple and elegant, and it's perfect for setting up a loom to make coarse fabrics like jute or heavy canvas. The advanced 7-wheel system. Okay, so the 5-wheel system is great, but what about finer, more delicate fabrics? For those, engineers needed an even more precise solution. And that brings us to the next level up, the 7-wheel system. It's basically an evolution of this same idea. And here's a look at the 7-wheel system. I mean, you can see right away it just has more gears, it looks a little bit more complex, but those extra parts, they're not just for show. They're what allows this system to have a much higher degree of precision. Now, at its core, it's working on the exact same principle as the 5-wheel system we just saw. It's still a positive intermittent motion, still driven by that same ratchet and pawl setup. The big difference is those 2 extra wheels in the gear train. They're what allow for much finer adjustments and a way smoother transfer of motion. Okay, and this is where the real genius of the 7-wheel system shines. The formula for the PPI is a little different, as you can see. The number of teeth on the change wheel is now divided by 1.015. So why that super specific, kind of weird number? Well, it's a built-in allowance for fabric contraction. See, finer fabrics have this tendency to shrink just a little bit, about 1.5%, once they come off the loom and are no longer under tension. So this formula cleverly pre-compensates for that shrinkage. It's designed to make sure the final fabric, after it's relaxed, has the exact density the designer wanted. It's just a beautiful bit of predictive engineering. choosing the right mechanism. So, okay, we've got two really clever solutions to the exact same problem, which of course leads to a pretty obvious question. So, why choose one system over the other? I mean, why would you ever use the simpler five-wheel system when the seven-wheel version is clearly more precise? Well, like with all great engineering, it really just comes down to using the right tool for the right job. And this table really lays it all out. On the one hand, you have the five-wheel system. It's simple, it's tough, it's robust. Yeah, its motion is a little jerky, but for heavy-duty fabrics like canvas that don't really shrink anyway, who cares? It gets the job done. Then, on the other hand, you have the seven-wheel system. It's way smoother, and it's absolutely essential for medium and fine fabrics where you need that built-in contraction factor to get perfect results. It's just a classic trade-off, you know? Simplicity versus sophistication. So really, here's the bottom line. It's a tiny, intermittent motion that creates one perfect fabric. The next time you actually feel the texture of your clothes, just remember the hidden genius that's chugging away inside the loom. That tiny, intermittent click of a single ratchet wheel, translated through a handful of gears, that is the secret to that perfect, uniform weave. It kind of makes you wonder, doesn't it? What other everyday objects, things we completely take for granted, are hiding a similar kind of secret mechanical genius right under our noses?